In this video, we are going to learn about dosage calculations. Our first outcome is to calculate medication doses using dimensional analysis. Secondly, we're going to learn how to find the dosage strength on medication labels. In our first example, the doctor orders doxepin HCl 20 mg PO at bedtime. We have available 10 mg per capsule. The question is, how many capsules will the nurse administer? The first thing you want to do when doing dosage calculation problems is find the order and what is available. In this problem, we have 20 milligrams are our order, and available we have 10 milligrams. Once we have those, we can set up our dimensional analysis. We always want to start with the order. So here you can see we have 20 milligrams over 1, and we're going to multiply it by what's available. We're going to have to put the 10 milligrams on the bottom because in dimensional analysis, we always want those to cross out. So the milligrams and the milligrams will cancel, and we will be left with our capsule on the top, which is what we want. So we're going to cancel out our milligrams, and we'll end up with 20 capsule over 10 by multiplying straight across. So we did 20 times 1 to get 20, and 1 times 10 to get 10. 20 divided by 10 will give us 2 capsules. So we need to administer 2 capsules. For these, it's also important to be able to visualize. So for example, we had 10 milligrams capsules. So over here on the right, we have a 10 milligram capsule. If we added another 10 milligram capsule, that will give us the 20 milligram capsules that we want. So 20 milligrams is the 2 capsules. Now, if you got an answer, for example, 20 capsules, you should know that your answer may be wrong. So these answers should always make sense. So make sure that your answer makes sense at the end, and then you'll know that your math is right. Our second example, we have the order reads Diflucan 150 milligrams PO daily. Based on the label, how many milliliters will we administer? This one has a label that we need to read. So if we look over here on the right, it tells us there's 35 milliliters with reconstituted, tells us the name, it tells us our strength, 40 milligrams per milliliter, and then it gives us some information about the drug. So what we're going to need, again, is to write down our order. So again, that tells us that the order is 150 milligrams, and then of the available part we'll get over from our label. So if you look over here where our arrow is pointing, 40 milligrams per milliliter, that is what is available. Now we're going to put it back into dimensional analysis. So again, start with our order, 150 milligrams over 1, multiplied by what's available. And again, we'll have to flip it because we want our milligrams to cancel out with our milligrams, and we have 1 milliliter on the top. So we cancel out our milligrams, multiply straight across. 150 times 1 gives us 150 ml. 1 times 40 gives us 40. And then if we divide 150 by 40, we get 3.75 milliliters. Now we need to round this to 3.8 milliliters because of our rounding rules. Under 1, we're going to round to the hundredths, and over 1, we round to the tenths. And that's based off of our syringes. When our syringes are under 1, each line is at the hundredths place. When our syringes are over 1, we have a line at the tenths place. So make sure you remember under 1 round to the hundredths, and over 1 round to the tenths. And that is how you do dosage calculations with dimensional analysis.